In this section for AMAT Trigo, we are exploring the sketch of Trigonograph. So by the meaning of sketch, right, you're not supposed to draw on graph paper. So by the meaning of sketch, you should also be showing like critical values. So later on each graph, there will be some critical values for you to take note of. So we'll be starting off with sine x, cosine x, and tangent x first. Okay, then we will extend the graph. Okay, and I will be showing you the steps. Okay, so for each of these graphs, like for example, sine x graph, okay, there will be something called a period and an amplitude. So right now I'm on the part on sine x. So the period for sine x is 360. So period is how much degree you need to make one wave. So for sine x is 360. So and one wave will look like this. Meaning, if I go and extend another 360, it will look like one more wave. So that's the meaning of period. So that is what you need to make one sine wave. Okay, so but of course, when you draw, you cannot be drawing freehand. So when you draw, right, you kind of divide the period into 4 sections. So usually you'll be something like this. So mentally you divide by 4. So that's how you get the 90, 180, 270, and 360. And there are some special values for you to guide you. So what do I mean by special values? Like when x is equal to 0, you go and punch calculator. It will be a 0. So you got a special point here. When x is 180, you punch calculator, sine 180, you will get a 0 as well. So you actually get 0 when you punch sine 180, sine 360. So, and you also get sine x equal to 1 when x is equal to 90. You can try punching sine 90 is equal to 1. Then you also try punching sine 270 is equal to -1. So these are what I will call the guiding point. So you should have all the guiding points, then you will do out a sketch. Do not draw it as a freehand. Okay, it will be quite ugly and sometimes you will land yourself into a wrong graph. So that is the idea. And there is something called amplitude. Amplitude is like the half the body height. So in a way, right, it's like the highest minus the lowest, and then you divide by 2. So in this case, right, if you do the highest minus the lowest and you divide by 2, you are getting 1. So that is the amplitude. That is the height of the wave, which is the height of your graph. So the height of the graph can change, the period can change. So later on, we'll explore how it will change. But we are now, at this moment, we're just exploring the basic graph. So for cosine x, the period is 360, and each graph looks like this. That means, right, if I've given you another 360, it will look like another wave. So obviously, we cannot be doing freehand. So again, the idea will be you divide the period into 4. Mentally, you divide into 4 when you're doing the sketch. So that's how we get the 90, 180, and 360. And you're going to be using special values to guide you. So this will be the special values. So if you punch these 2 values, you will get 0. If you punch 0 and 360, you will get a 1. If you punch cosine 180, you get a -1. So this punching of calculator will give you guiding point. So from here, you're supposed to draw it in a curvy manner. So some of the common mistake will be, some people actually draw it like a straight line. So if you draw it like a straight line, your cosine graph turns out looking like the inverted triangle. So you'll get penalized for that part. So do not go and draw in a straight line. You don't join them up in a straight line. So there are some curvature. Okay, and again the amplitude is 1. Okay, this is the amplitude. So it will be from the highest, you do the same thing, highest minus the lowest, divide by 2. It will give you the amplitude. Okay, and then for tangent graph is usually the more confusing one. The period is 180. So by right, this one is how a full wave look like. So you will keep on doing this. So that is a tangent graph. Okay, the feature, okay, there are some special values that are not given here. Okay, so again, right, I'm going to divide the period by 4. Okay, so actually this part is the period. So you should divide by 4. Okay, here they only show the special values of x equal to 0, you will get tangent 0. Then x equal to 180, you also get a 0. Okay, so I'm just going to stay within a period first. So if that is the period, right, the amplitude is half the period. Okay, you might want to think this way. Not amplitude, sorry. The asymptote is half the period. Okay, the asymptote here is half the period. And then, right, there's also one more special values here. Okay, it will be tangent x equal to 1. It will be equal to 1 when x is equal to 45. So here, so this one will guide you. Okay, there is no amplitude here because the graph will keep extending towards the asymptote. There's another special values, -1, that happens when x is equal to 135 here. So it actually guided you. So that is like one period. And then if I go on another period, okay, maybe I use green color. So here I go on another period. Half the period will be the asymptote. And here there will be a guiding point. So this value here, you can bunch calculator. 180 plus 270 divided by 2. So any values that you're not sure, you just punch calculator. So here there's a 225. So another one here, this is a 315. It will correspond to a -1. Okay, so anyway, later on I'll be showing you how to the steps to draw. So at this moment, you just know this is the shape of individual graph, and then you use a special values to help you to draw it nicely, not freehand. So even though it's a sketch, right, you still need to show important points, which are the special values to guide you to get a proper shape. Okay, so all these are the basic graph. Okay, we are going to change the graph a little bit. So basically, right, we are going to add a number to the graph. So we're going to multiply A to the graph. So the effect of multiply A will change the amplitude. The graph will become taller. So if you take a look, okay, so A is the amplitude. It will make the graph taller. Okay, maybe you cannot see the effect. Okay, you will see the effect, right? If you cannot see the effect on tangent graph, but if you do this part, right, you will get an A. And then if you do this part, you will get a -A. So later on, I'll be showing you using numerical numbers. Okay, so again, no matter what, the period, so this is like a formula for the period. So the effect of B will change the period. So if you're going to be drawing like sine 2x, sine 3x, cosine 3x, okay, this will change the period. So in a way, right, this is the formula for the period. So sine and cosine, they got the same formula. Period is tangent got a different formula. So no matter what the period is, you're still going to mentally divide by 4 when you're doing the sketch. So later on, I will show you the effect. So if we add in a number before the function, that number is responsible for the amplitude. So that number is also responsible for the highest and the lowest. So the value of A will determine the highest and the lowest for the graph. The value of B will decide the period. So the effect of the period is sometimes you're squeezing the wave or you're going to extend the wave. Whatever is it, calculate the period, and when you sketch, right, you got to divide by 4. Okay, so that is the idea. And there is this thing that some of you might not understand. So there is this sign that you may not understand here. Okay, so anyway, amplitude is always positive. So amplitude is like the height. So height cannot be negative. So the values of A will determine the highest and lowest. That's why there's this thing called the range. The range of the graph. So the range of the graph is in such a way that this is the highest and that this part is the lowest. Okay, same thing here. This is the highest, then this is the lowest. So sometimes A can be negative. So maybe this will be a negative. But if we talk about the amplitude, it will just be 2. You cannot have a -2. So if let's say you got a -3 here, the amplitude is 3. You cannot have a -3. But what is the effect of putting in a negative? So later on, I'll be showing you. Okay. So for the tangent graph, after you calculate the period, the asymptote is still at half the period. Okay, so I will carry on. I will show, this is just the idea first. I will show you the steps and I will show you some numerical samples so it's easier to relate. So eventually, right, so we explore, right, there's a A. The value of A will change the amplitude, the height, and the highest and the lowest. B will change the period. Okay, and then right now we're going to introduce a C. C is like a shifting effect. So this C here, right, is to shift the graph. So you can, so if C is positive, means, right, you shift the graph up. If C is negative, you're going to be shifting the graph down. Okay, so there are A, B, C that will be playing around. So if you look back, this is the basic shape. Use the special values to guide you in the basic shape. So if we change it, the generic graph will be, there will be a value of A, there will be a value of B. So you got to be sensitive to the value of A and B. And then right now we're going to add on a C. So the C is responsible for the shifting. So I'm going to show you the generic steps first, and later on there will be some numerical example. Okay, so if you follow closely to the steps, you might not get so confused. So the first step, I will usually calculate the period. So I'll calculate the period and I will divide the period into 4 sections to facilitate the drawing. Then second step, I will check for the amplitude because the amplitude will tell me the highest and the lowest. And then from there on, the third step is the one that I will add in order to sketch, right? Remember to add in the special values. So the special values are the one that will guide you in the shape. So later on, I will show you. So usually I will draw for one period first, and then decide, do I need to have more periods or do I need to have lesser period? Okay, then eventually after you draw, then you decide whether do you need to shift or not. So it's after the third step, then you do the shifting. If you try to do the shifting beforehand, some of you might draw the wrong graph even without knowing it. Okay, so this will be the 4 steps: period, amplitude, special values, and then the shifting. So have a generic idea first before I show you some numerical example.